In this video, you will learn how to solve quadratic equations with perfect squares. So example 1, here we have h squared equals 36. Now our objective is to get h, or whatever variable we have, by itself. So in this case, we do not want the squared with the h. So to get rid of the squared, we do the inverse of squaring, which is taking the square root. So I take the square root of both sides. When I do that on the left side, the square root of a square will undo each other. I'm left with an h over here. On the right side, we have the square root of 36. Now, just one thing to take note of is that when you're solving an equation and you're working with squares and square roots, remember that when you take the square root of both sides, we have two answers. We have a positive or a negative. So h could equal a positive square root or a negative square root. So the square root of 36 would be 6. So it could be a positive 6 or it could be a negative 6. I can write my answer like this, or I can write it as two separate answers where I have a positive 6 and then a negative 6. Either way, this is the same thing. And we can double check our answer because if we plug a 6 back in for h, 6 squared would be 36, and also negative 6 squared would equal 36. So for all of these problems that we're going to walk through, the key is getting the squared term on one side by itself, and then the constant over on the other side. Because once we have that, we can then take the square root of both sides to solve and find our variable. So for example 2, we see 6y squared equals 54. Now, like I stated, we want to get this y squared by itself. Alright, so before I take the square root of both sides, I want to get rid of the 6 in front. So the 6 is being multiplied, and I can move it over to the right side by dividing. So if I divide both sides by 6, I now have y squared on the left, and then 9 on the right. Now at this point right here, I can solve by taking the square root of both sides, because I have the squared part by itself and then the constant over here on the right side. So I can take the square root of both sides. When I do that on the left side, the square root of the square will undo each other. I'm left with a y over here. On the right side, we have the square root of 9, but don't forget it is a positive or negative square root. So the square root of 9 is 3, so a positive or negative 3. I could write my answer like this, or I can write it as two separate answers where I have 3 and negative 3. And again, we could double check our answer by plugging these numbers back in, and we would find that we would get true solutions back out. Now for example 3, instead of just an x being squared, we have x minus 3 squared. Now the concept is exactly the same. The squared part over here is all by itself, and the constant is on the other side. So what I can do is I can immediately take the square root of both sides, which will get rid of the square. When I take the square root of the left side, the square and the square root undo each other, and I'm left with x minus 3. And then on the right side, I have a positive or negative square root of 100. Well, the square root of 100 is 10. So I have x minus 3 on the left, and then a positive or negative 10. Now at this point, I could either keep it like this for now, or I can separate into two different equations, where I have x minus 3 equals 10, or x minus 3 equals negative 10. For many people, this might be easier to visualize what we're doing, and you might make fewer mistakes if you separate into two equations. If you do this, you're going to add 3 to both sides. We get x equals 13. Same thing over here. We get x equals negative 7. So I have two different answers, x equals 13 or x equals negative 7. If you wanted, you could keep the plus or minus in here at the same time. So I have x minus 3 equals plus or minus 10. And then to solve, I add 3 to both sides. So now I have x equals, here we have 3 plus or minus 10. Once you get to here, just don't forget to finish it off. So we have 3 plus 10 is one answer, that's 13. 3 minus 10 is negative 7 for my second answer. So it doesn't matter if you separate into two equations or just do it as one equation. Just don't forget this part right here can be simplified further. So either way, your answer is 13 or negative 7. For example 4, we are doing something similar as example 3, but now we have a coefficient in the front. So just like we did with, I think it was example 2, when you had a number in the front, you want to isolate this squared term. So we want to get rid of this 4 with the x minus 3 squared. So to get rid of it, we need to divide, because it says 4 multiplied by x minus 3 squared, so the inverse of multiplication is division. So I divide both sides by 4. I now have x minus 3 squared equals 8. So now at this point, because I've isolated this squared term, I can now take the square root of both sides. When I take the square root of both sides, I'm going to have on the left side the square root and the square undoing each other. So I'm left with an x minus 3 over here. And then on the right side, I have a positive or negative square root of 8. And then I can solve by adding 3 to both sides. So now I have x equals, and then we have 3 plus or minus the square root of 8. And by the way, it's always best practice to simplify radicals if possible. Here the square root of 8 is the square root of 2 times 2 times 2. And notice we have two 2's here. So I can pull out 1, 2, because there's one group of 2's. And I'm left with a 2 on the inside. So I can rewrite this as 3 plus or minus 2 times the square root of 2. I can leave my answer like this if I want, but realize that the plus or minus means we have two answers. One would be 3 plus 2 times the square root of 2, and then the other would be 3 minus 2 times the square root of 2. So either way you want to write it, this is the correct answer. Just realize we have two different answers. Now for example 5, we have y squared minus 10y plus 25 equals 16. Now when you see this y squared, your first thought might be to get y squared by itself. But this one's a little different because we also have a minus 10y here. So it's not just this one term with a y, or y squared, but now we have two different terms with y. So I want to keep y on the same side. And what I can do is I can actually factor this left side. When I factor, I'm going to get two sets of terms in parentheses. Here we have y times y to get y squared. And then if we do negative 5 and negative 5, that would multiply to give me a positive 25 for the last term, and would add to give me negative 10 for the middle term. So this would be the same thing as y minus 5 squared. That's equal to the 16 on the other side. So we factored, and notice this is a perfect square. So at this point right here, I can take the square root of both sides. So when I take the square root of both sides, the square is now gone. And I'm left with the y minus 5 over here. And then don't forget we have a plus or minus square root of 16 on the right side. Well, the square root of 16 is 4. So I have a positive or negative 4. And then I can solve for y by adding 5 to both sides. We now have y equals 5 plus or minus 4. And don't forget to finish this off. We have 5 plus 4, which is 9. 5 minus 4, which is 1. So I have two different solutions, where y is 9 and y is 1. And I can always double check my answer by plugging back in to the original equation. And if we do that, we would find that we have true statements, which confirms that we have the correct answer. So the key is getting a perfect square on one side and a constant on the other side. And this one we could force to become a perfect square by factoring, and then take the square root to solve. Here we have another example where we are increasing in difficulty. We have now 3 times 2x minus 1 squared minus 4 equals negative 13. So the best way to solve this equation is we want to isolate this term. So isolate this perfect square. Alright, which means we need to get rid of the 3 and the negative 4. Once we isolate, we can take the square root of both sides to solve. So we treat this the same way we would treat solving an equation with just a regular variable. To get this by itself, we work in reverse order of operations. So we see a subtraction of the 4, and we see the multiplication of the 3. So working in reverse, we take care of subtraction first. We do that by adding. So we add 4 to both sides. We now have 3 times 2x minus 1 squared equals, this would be a negative 9. And then from here, we can get rid of this 3, which is being multiplied, by dividing both sides by 3. So now we have 2x minus 1 squared on the left side equals negative 3 on the right side. So we've isolated, and now we can take the square root of both sides to solve. So I take the square root of the left side and the right side. On the left side, the square root of the squared becomes a 2x minus 1. So this cancels out. I'm left with 2x minus 1. And then on the right side, we have a positive or negative square root of negative 3. Now right here at this point, we see a square root of a negative number. What this means is that our solution is not going to be real, because we cannot have a square root of a negative number and have a real answer. So it's not real, or we can say it's imaginary. And as you progress in your study of algebra, eventually we'll work more with these imaginary numbers. But for now, at this point, we can stop here and say that our answer is not real or imaginary.